There we go. So I do record these and we put them online later today. The primary home for the videos is in the Think Data Thursday group. On the right-hand side of the screen, there's a link to all of the videos. But recently, we have also added them to the Tableau YouTube channel. And so there's a playlist on the Tableau YouTube channel that you can go to and watch them there as well. So trying to get as much exposure as we can for these. Today's Think Data Thursday is I didn't know that was Tablossible, and we're going to be seeing some great network diagrams and chord diagrams presented. We have 3 panelists that are presenting today. Jeffrey Shaffer, let me go ahead and share. There we go. Jeffrey Shaffer. Jeffrey Shaffer is Vice President of Information Technology and Analytics at Unifund. He's also an adjunct professor at the University of Cincinnati in the Carl H. Linder College of Business, teaching data visualization. He's a regular speaker at conferences, symposiums, universities, and corporate training programs on the topics of data visualization and data mining, and has taught data visualization at the KPMG Advisory University. He was the winner of the 2014 Qualified Self-Viz contest, competed in the 2014 Tableau Iron Viz competition, and led the Cincinnati Tableau user group to victory in the 2015 War of the Tugs. He's also a Tableau ambassador for social media. And next after that we have Chris DeMartini. Chris DeMartini came to Tableau community through his work in network graphing. Since his arrival, Chris has focused on incorporating dynamic aspects to his visualizations and has posted a series of guest blogs on DataBlick, including the likes of hive plots, circular networks, and even a family tree. His passion for data analytics and all things Tableau have led him to challenge the notion of whether a visualization technique is possible. In addition to his work with DataBlick, Chris has over 10 years experience with the risk and audit profession, previously working for Deloitte and now for Visa. He's been focused on the application of data analytics to the audit process and is viewed as a leader in his field. And our third panelist today is Noah Salvaterra. And Noah Salvaterra is a consulting partner at DataBlick. Noah Salvaterra first appeared on the Tableau scene through a series of guest blog posts on drawing with numbers. This is Jonathan Drumby's blog, for those of you who know him. These posts push the capabilities of the software to produce things like fractals and 3D maps, even a fully functional Enigma machine. These posts, along with his work on the Tableau community forum, led to Noah's selection as a Tableau Zen Master in 2014. Noah's unique blend of mathematics, artistry, and curiosity combined to form a toolbox that even others Zen Masters call ridiculous. He's demonstrated the highest order talent in the rapidly developing clear, fast, and beautiful visualizations that drive decisions, delight his clients, and exceed their expectations. So there we go. Up here, and seeing Noah has also joined the team here this morning. With that said, I'm going to go ahead and pass things off to our first presenter this morning, which is Jeff. Jeff, I'm going to make you presenter, and I'm going to unmute you. So just a second here. And Jeff, you're unmuted.
Can you hear me?
Loud and clear.
Great. So I'm just going to dive in and get started here. First off, everything that I'm going to share with you today is going to be posted on my blog, so nothing that I show is going to be hidden or you have to hunt down. If you go to Data Plus Science, that's my blog. On the Insights page, there's a Think Data Thursday that I just posted a few minutes ago, and that page itself will have everything that we talk about today. It even has all of the example workbooks that I'll walk through. So I'm just going to dive into Tableau real quick. Most of the things that you see today are really math functions. I think the primary thing that all three of us are going to talk about are really based on math. Even the logo that you saw, the Tablossible, font that you might have seen on the screen. Chris created that using Bezier curves, and we're going to walk through some of those visualizations and how we create some of that stuff. For me, it all started with a post. Andy Kriebel had posted a visualization that he found that was sort of a slope graph with a sankey style slope graph, and so I wondered about making that in Tableau. And so to do that, I use a sigmoid function, and this is something you would use in data mining, with a logistic regression. Not to get into the details of that, the formula itself is pretty simple. This formula down here really creates that curve, and so that is really at the heart of how we create a lot of the stuff that we're creating here, whether it be the tree diagrams that we show, the sankey, the slope graphs. It really is that curve, and to do that in Tableau, we're really just plotting points along an x-axis, and so we create dummy values in here between -6 and 6, and we plot those points on a line. And so all we really need to do is know the origin of the point on the left and the point of the destination on the right, and we can plot those points away. And so you'll see this function over and over again in most of the work. The data itself, I just dummied up some data here it's real data. It's from a website, but just kind of dummied it into this viz here. So this is the top universities across the world as ranked, and so we can see top 10 universities and their position 1 and position 2. Those are going to be the points at -6 is position 1. The points at +6 are position 2. And so your data really just looks like that. Now, in this case, what I want to outline here is Cambridge in 2014 was maybe the 7th university in the world, and in 2015, maybe it's the 5th university in the world. And so when we look at that and we plot that, it looks like this. So the data, just going into the data itself, there is a link function that I use, and so in Excel the data is actually really simple. There's not many fields at all. I can just open that for you real quick, and there's really just the universities, the rank of the positions, and then this link field, and this is also on the website too, so you can download this Excel spreadsheet, but it doesn't get much simpler than that. It's just name of the university, 2014 their rank, 2015 is their rank, and then this field called link. And this link links up to another page, which is also really simple. It's really just one column. It's the values for that x-axis of -6 all the way to 6. So at the heart, that's what the data looks like. We join that data in here just on that link, and when we do that, every point, every university, every row of the 10 universities becomes 49 rows because it connects to that link. And so we plot that -6 to 6. It was the 7th university on the list going to be the 5th university, and we can see that it just plots, and then we can make that, of course, a line, and we have our curve. So in that example, really quickly, here's just a blank workbook. We have that sigmoid function. That sigmoid function is very simple. You just copy that. You're going to use that. Your curve then becomes the measure of your distance. How big is the university going from 7 to 5? So 7 minus 5, and we use that sigmoid function. Creating the viz couldn't be easier once you have these points. You're going to put T up here, which is your points of -6 to 6. You're going to put your curve on your rows. Now you have that. Now you need to split it up into whatever we need to get the level of detail that we need. So I guess we need the names of our universities, but we also need to put those points in here, and this is a key. A lot of people miss this. We need to convert this to a dimension so that we have all of our points, and so that is really at the heart of these curves. I changed the dots now to a line, and it's ranked upside down, so reverse my axis. I'm just going to go 1 to 10 instead of 10 to 1, and there's my top 10 universities. Caltech was 1 in 2014, and it's 1 in 2015. So you can see once your data is set up, and the data is really easy to join, this is just 3 or 4 fields that are used to do this. Your final result, expand out your axis on the x-axis a little bit so you can fit your labels, and that's how we create it. That math in here can really go to all kinds of other things. For example, instead of using a sigmoid function, if I just plotted in a sine, I can put the sine in there. And same thing if I go in here and just edit sine of t and make it the cosine of t, I get upside down. It's now a letter M. And all of these things that we're doing at the fundamental is really just math. This is the same thing. There's no data in here except the -6 to 6, and I simply used a formula for plotting that. So there's the heart, there's my X using the sine of t, and there's the Y, a little bit more complex, but there's all kinds of math formulas for these shapes. In this case, I referenced it down here. That's just the equation to draw a simple heart. So at the heart, no pun intended here, of what we're doing is really these math equations. So let's see some of this in practice. I'm going to kind of walk through what we did with it. So this is the very first example of that. I'll call it a slope graph because it really is a slope graph, but a sankey style because it's weighted to the distance, meaning that Wyoming is falling from 13 to 34, so the line is weighted to show that distance, where if something isn't moving very much at all, the line is very thin, which is really kind of what a sankey diagram does. And so that was the first thing that I recreated. The original graph, this is the original image of that very first chart. That was the Tableau version. There's the image. So that's what the first chart looked like, and there's the Tableau version of that chart recreated. Then the next question was how to build it. So there's instructions in here of how to build it, walking through all of those things, all of the steps of moving all the pills to the various locations. Then somebody else asked, well, what about doing multiple charts? What if I go, multiple years from 2014 to 2013 and 12? And so we have that here. And with a nice hover, we can see how something is moving from year to year. And that's really what I think a sankey is really good at, is to show flow. So then I took a shot at redesigning my Duke Energy bill. That was sort of the next thing I posted. Duke Energy had these wonderful pie charts to show me my data, so I decided to put it in a sankey diagram, and so that was the next thing I did, and this is the same thing. Instead of plotting position 1 to position 2, just imagine there's 100 positions from 1 to 100%, and it's going to 1 to 100 positions on position 2. So it's the exact same concept, and so that was the next thing. And that sort of developed. We figured out better ways to get the data in, which is what I just showed you, modeling that you don't have to shape your data ahead of time. You can actually just have your data in a simple format with and linking it. Then somebody said, well, can we build a more traditional sankey? This was posted on the Tableau community discussion and said, can we build something like this? And so I did that. I recreated that in Tableau, and sort of that was the next thing. This one here is in one workbook. This one here is a little with floating tiles. I think is a little better variation, but gives us, again, a nice hover to show us the flow as it goes through in these financial categories. That kind of expanded again, and Olivier Catherine in France discovered that he could use polygons, and the same exact method that we had before, except he created a min and max formula. And so instead of plotting all of these little individual lines going through here, he created polygons. So there's a max and a min set for each one. He did a guest blog for me, and it's all detailed here, where he has the min and the max, and he sets that and really takes it to the next level, where you don't have all the little dots or even lines. He's actually doing it with shapes. Moving on to the next one, he posted this also to the Tableau forum, and there's some other beautiful examples that he has of some of these sankey diagrams, again, with all of his steps that he had. Moving on, Chris Love then used data densification to make the process even a little easier, I think. Some might find it easier. Once it's set up, it makes it very simple to put these things together, but combining the stuff that I did and Olivier did, he took that and applying some data densification, created some additional sankey diagrams, and he outlines those steps as well on that blog. Let's see here, moving on to the next one. Somebody from Zurich, Switzerland pinged me. I get a lot of emails about sankeys, as you can imagine, and somebody said, can we apply the same thing to this chart in D3 and create a node link tree diagram? And the simple answer is yes, the same thing applies. So in Tableau, it's really done in the exact same manner. You'll see we have the sigmoid function, we have our T, we have positions. I use a dual axis, one thing that's different, so that my dots, I can color my dots and have the dots for the nodes versus the lines that you see here. Of course, it can go upside down, like a tree and a decision tree. So org chart was the next thing that was kind of thought of, and labeling, to see our nodes, and certainly could collapse them if we wanted to do that. And moving on here, see my controls are getting in the way, so let me close some windows. Olivier, again, took that to the next level and did some flow diagrams, some decision trees, using the Superstore data, I think is what he used in here. So again, he outlined step-by-step how to do that. He really, in an effort to make the data simplified, I think that's what he was outlining here, creating that tree structure of the data to make that easier. And you can see with some calculations that he does, I think he makes it much easier. And then a couple in practice. So this was my viz that was the winner of the quantified self last year. A real subtle sankey, slightly different, building it into the graphic here, but in this case a trumpet that has the music playing to the composers. Over here on one side I have 100 positions, 100%, but on this side I did something a little different where it's going to 200. So I have a 1-to-2 relationship. In other words, row 1 here would actually go to row 1 and 2 over here, and row 2 would actually go to row 3 and 4. And so it's basically doubling to spread it out in that case, and that's how that was created. Matt Chambers did a wonderful viz of the day. He really took the sankey style slope graph and really moved it into complexity here, showing the path of where a player comes from their home state to the college that they go to, ultimately to if they're drafted or not drafted. And then Chris Love, probably the most complex I've seen as far as an implementation of this, the history of the Football League, one of his Iron Biz competition entries. Really well done, showing paths that are just tremendously complex, using Alteryx and putting that data together. I thought I would show just a couple other things just different in Tableau that you might not have seen. A fishbone diagram is really useful for cause and effect, and so I decided to put that into Tableau, and the main reason I did, sure, I could easily draw that in, Photoshop or Excel, but I wanted to quantify, I wanted to create a quantitative scale for the lines, and so I created a weighted fishbone where I could say, okay, well, how many, instead of just having the causes, what's the number of the causes? And so by putting it into Tableau and doing that, I can not only encode by size of the bar, I could also encode by color, or both. In the end, I thought the color, using the color to quantify that this path was the most with 12 was something of interest. But again, that was just done with plotting points on really a quadrant XY. One of my students at UC asked about doing a Venn diagram, and I don't particularly find this a useful tool, but the previous attempts at the Venn diagrams by some of the people in the community were really trying to put shapes on top of each other, and while it worked, it wasn't it wasn't mathematically correct. The area of that was overlapping in the circles certainly wasn't right and hard to control when you're using the size of shapes in Tableau. So this is actually done again with math. That's a math equation for each circle that you see, and they're plotted separately. But the nice thing here now is that because they're plotted like that, I can move them and I can recalculate and show that this is only 4.6%, this is 21%, this is 14%, and as I move those circles to various positions, even outside of the circle, I can recalculate and show that there's zero overlap. So that was another interesting use of math to do some of this stuff. And then last but not least, I did not create this, but people have done some arc charts, and I thought this would be an interesting thing to show leading into what Chris is going to show and Noah. This is, again, just using some math for plotting points from A to B, and Chris is going to show you some even more impressive implementations of that. So I thought I would end with that. I think I can pass to Chris at this point.
Thank you, Jeff. I'm going to unmute Chris and pass the ball to him. Chris, you are now presenter, and I have unmuted you.
Can you hear me okay?
I can, yeah.
Okay. So I'm newer to the scene than Noah and Jeff are, so one of the things I wanted to touch on today is around leveraging some of the great content that's out there and that's been shared. So you just saw Jeff walk through a bunch of examples of sankey style diagrams, and obviously if you're going to take it upon yourself to put one of those into practice, it would be a good idea to leverage all the work that he's done and shared. So I'm going to go through a couple of examples of things that I've put together and definitely point out where and how I've gone about getting kickstarted on those things. So,
Chris, can we go ahead and get your screen shared real quick? Make sure.
All right.
You need to make them for later.
There we go. Sorry, found it. You see now? Patrick,
Yeah, we're good now. Yeah, yep, we're all good. Thanks.
Okay, sorry. All right. So what I wanted to start off with is just to show this visualization that was done by Robert Rouse. And this just goes to show all the various people that are out there contributing content day in, day out in the Tableau community. So it's really a great thing. It helps people be more creative and evolve their design more quickly throughout the environment. And one other thing I wanted to point out on this note is, and I promised Jeff in the training to show you this, but on his site he has a Tableau reference guide, and this is really a great starting point if you're trying to find out how to do specific things in Tableau. So he's got a lot of the sankey diagrams on here and other graphing types as well. He also has pieces around JavaScript API, using colors, level of detail counts, so on and so forth. So really a great, I think pretty close to a one-stop shop as you can get in terms of all the various things you can do in Tableau. So just wanted to give Jeff a shout out for that. Thanks for putting it together. So what I want to go to next is the circular diagram that I put together earlier this year. That graph was really based off of Joe Mako's handoff map, which you see here. And so this workbook that Joe put together is really a fabulous piece of work. And if you ever have a need to plot anything in a circle, I would definitely recommend finding this on the forum and keeping a copy of it handy. One of the things I really like that he added into this is this spread rotation capability here. So as you see, as I move this along, the nodes are moving along with it. And so what I did is I leveraged that to put together my network circle that you see here, and really taking on top of what Joe did and transforming it into a network diagram. On top of that, I added this capability to put nodes in the middle of the diagram. So you can see those there, and you can adjust dynamically depending on your preference and or the network that you're analyzing, how many of those you put into the center of the diagram. You can add highlighting to that shown here. And then obviously, like I mentioned, the spread rotation I showed it, I just carried that straight through because it's such a great idea. And you can see that taking effect here. One of the things I want to spend time talking about today was the Bezier curve, which Jeff mentioned briefly throughout his discussion. It works pretty similar to how the sigmoid equation works. It's just a different formula. So one of the places that I went to try and learn more about the curve was the wiki page, which has all the various formulas that you would need to implement the curve and the various orders of the curve. You can get more and more complex with the curve as you go higher up in the order. There's a visualization down here on the wiki page actually that's really helpful, which is here. You can zoom in on that. And so if you're looking at this, just to the point Jeff made about the sigmoid function, is you have a start point, which he referred to as position 1 in his example. You have an end point, which he referred to as position 2 in his example. But with the Bezier curve, you also have a control point. And what the control point allows you to do is modify how the curve looks from the start to the end point. Again, here you see the implementation of T, which is along the lines of what you saw with Jeff's example. And really, at the end of the day, we're going from the start point to the end point with 100 points in the middle. One of the things that I used to implement this type of curve in Tableau was Noah's 3D blog. And so on his 3D blog, he talks about the concept of data identification. So you saw in Jeff's example, he was talking about the joining of his link that he mentioned, and in that link join that he was doing in his data source, he was basically expanding one row into, I don't know how many, 36 rows or whatever it is he needs for the sigmoid equation. This is another way to do that same thing. So you're seeing two applications of that type of implementation in Tableau, one using densification and one using that join that Jeff showed you. One other thing I wanted to mention real quick is this Fibonacci sequence view that Noah did is pretty awesome. So if you have not seen that, I would definitely recommend going get that. So the next thing I did when playing around with the Bezier curve is I started trying to manipulate it within Tableau. So here I've plotted the curve with static endpoints. So my start point is negative 100, 0. My endpoint is 100, 0. And what I've done is parameterize my control point. So as you move the control point around, you can see the curve react to where you're placing that control point. And this really helped me get a better understanding of how and where I needed to place the various points of the function in order to get the curve to react the way I wanted to. From there, I started playing around with the placement of the endpoint. And so in this example here, you have the curve being shown and moving the control point, keeping the endpoint static. Here I'm keeping the control point static and moving the endpoints around. And so really here I just started experimenting, putting all the nodes on the x-axis, putting them on the y-axis, putting them on both axes, x and y, and then also playing around with putting some of the nodes on the top and some on the bottom of the x-axis, moving around the number of nodes that are plotted in that fashion, just to try and get a better understanding of how the placement of those nodes would affect the curve. From there, I worked that into the high plot that you're seeing here. And really what the high plot is at the end of the day is a start and an end point and a curve in between. There's the same type of highlighting that I've shown you already on some of the other views that's available here. And really an interesting implementation in Tableau. So from there, the next thing I wanted to show, Jeff hit on already, so I'll go through it pretty quickly. But he did this great post, which he already talked about, around the node-based tree diagram. I was talking with my mom, who was trying to put together she has put together our family tree, and I was trying to help her with investigating the generations of our tree. And one of the things that came to mind was this post that Jeff did and trying to adapt this to our family tree. And so that's what you're seeing here. And one of the things I tried to add to this was the capability to drill throughout the generation. So you're not just limited to the view that you're seeing here. It's not based on the data that's being loaded in. You don't have to go into Excel and make a change in order to change the view. So I worked on dynamically placing the nodes was a big thing. leveraging Jeff's sigmoid equation to create these curved lines and allowing the user to go in and dynamically reset the root node in the direction of the tree. And so here you can see going from the ancestor view of the third node, now we're looking at the descendant view of the, whatever name it is, 71. You can see they had 3 children. Up to 3 children. There's one that we've done more research on. They have so many children, and so on and so forth. So that's one thing that I was able to get to a lot quicker by leveraging some of the work that Jeff's done. The next thing I'm going to talk through is a novel graph type that we posted on Databook about a week ago. And so what you're looking at here is referred to as the jump plot. And with the jump plot, really the goal of this graph, what it's best used for, is to identify bottlenecks in a series of events. So if you have a process of 6 or 7 steps that's going on, and for some reason it's taking longer than you would expect it to, you can visualize the workflow through that series or sequence via the jump plot and try to identify where those distributions are, seem like an anomaly. What you're looking at here is an adaptation of that to the home run data from Major League Baseball last year. Basically, each of the checkpoints or nodes are the home runs being hit by the individual, and the hops, or in this case the Bezier curves, are reflecting the amount of time that it took the individual to hit that home run. So just as an example, if we were to focus in on somebody like David Ortiz, as you look at his specific information, you can see he started out above average. Just to note, this is a threshold-based jump plot, so you can see that he's actually above the average throughout the early part of the season, and then towards the end he slows down a little bit, but he never has a hop take more than 15 days, which is reflected here. We compare that to somebody like Edwin Encarnacion. Last year he had a really good start to the year. He was hitting home runs really quickly. Then all of a sudden it took him 46 days to hit his 27th home run. And so that could be because he got hurt. It could be just because he had a slump. There's a lot of reasons why that could have happened. But the point being here that the graph type can help you identify things like that. Lastly, you can see overall against the whole population that Nolan Arenado had the most time elapsed between home runs of 78 days between the 6th and 7th. And Justin Morneau the second most with 59 days between 13 and 14. If you're interested in the jump plot, there's more information on it at jumpplot.com. So here's the website, and within the website there's information on how the graph type works, ways that you go about plotting things. There's also this page around variations that you can use in case you have high volume sequences or anything like that. So that's a pretty interesting piece. And as well as implementing that in Tableau, we have a blog that we did on Databook last week where you can go through exactly how you would need to follow the steps to implement a jump plot in Tableau. So definitely reference that. The last thing I'd want to say is, as I was talking about leveraging shared content of others, of course, when you're doing something like that, you want to make sure that you're giving those people credit where it's due. So do be careful to do that if you are looking to leverage some work and get your workbook jump-started. So that's all I have, Patrick. If you want to go ahead and move it over to Noah.
Okay, I'm changing the presenter over to Noah. Thank you so much, Chris.
Yeah.
Okay.
And am I presenting now? Do I still need to do something here?
Nope, not yet. Noah is the presenter, but he is not presenting yet. He needs to share screen. And,
okay.
And it's coming up now. Thank you. Yep.
Working on our website optimization right now on Databook. Clearly, we're going to put a little time into that. But so I just yesterday evening finally posted my chord diagram blog post on the Databook website. It's one of the most common questions that I've seen on the Tableau forum is just a picture like this chord diagram picture with a question, can I make this in Tableau? It's been sort of frustrating for me to see those questions asked because usually the answer given was something along the lines of no. That no, you can't, but here's the link to Circode, which is an online tool that you can plug a matrix in and spit out a chord diagram. That didn't seem adequate to me because I think a chord diagram can be a really complicated thing to look at. I'm actually glad that Jeff and Chris covered most of the math background because math is hard. So so hopefully I'm not going to show you anything too complicated. But I think interactivity is really a key to using chord diagrams and having it be a useful presentation. So it made me sad to see these flat image presentations being used in Tableau. I wanted chord diagrams in Tableau. But it was something that I had sort of thought about, but I didn't really decide to attack it for some time afterwards. The way I came back to chord was when I saw this Robert Rouse viz that he had tweeted that's cross-references in the Bible. I saw this picture and I thought, oh, this looks like something that I've seen before. And it wasn't Bible related when I saw it. It's actually lines in hyperbolic space. Oops, yeah, I'm gonna talk about a little math. But when I saw this tweet, there were a series of tweets that I sent out afterwards because I recognized this looks a lot like lines in hyperbolic space, and there is a transformation of hyperbolic space. There's two different models, well, more than two, but two that are useful here. That you can go from this half plane, this upper half plane, to disk, unit disk. And let's see, I had this somewhere here. So I tweeted out this picture, which shows here's this half plane version, and here's the unit disk version. And I said, well, okay, the math to go from here to here is easy. Getting circles, half circles on a half plane is pretty easy. So why don't we just apply the math and we've got a chord diagram done, right? So I tweeted a couple equations to do that. I looked in Jeff Shaffer because I know he had looked at chord diagrams before, and but maybe a week or so later, I thought, well, why haven't I seen a blog on chord diagrams yet? Like I sent the equations and it should be done. So I decided to look at them. Turned out both equations completely wrong. Don't do complex arithmetic in your head was my lesson there. But I decided to tinker around with it a little. And the first version of my chord diagram actually looks like this. This is the hyperbolic version of chord diagrams, where everything is a circular. There are no Bezier curves on this particular version. So I'm transforming data on the boundary of the circle to the upper half plane. I'm completing the circle, and then I'm throwing it back onto the disk. And the one refinement on this that I was very proud of is that there is a branch point where things go up to infinity, and those were very jagged circles. So I rotated those around so that I moved them before and after the transformation. So I like this version, but it wasn't that satisfying to me because I think chord diagrams are sort of a chart type that people are familiar with, and when you see chord diagrams around, they're Bezier curves exclusively. So that was one thing I was decided I might want to do differently. Another thing I decided I didn't like about this was that I had pre-processed the data a lot. I had worked with it and done ETL to it in advance so that I could get these curves easily out of Tableau. And I thought that doing that as a blog post has some limited novelty, but it's not very useful. I have a history of doing blog posts that aren't very useful, you know, like a Tableau Enigma machine, which I don't know, maybe some people are using for something, but it's more sort of figuring out what I can do and having fun with it. And I wanted to have fun with this, but I also thought chord diagrams might be useful, and so I'd like to make it in a way that other people could plug their data into it. So that was sort of one thing that I tried to do. So it wasn't my intention, I guess, Jeff, to poach your blog idea that I knew you had for some time, but it was really just wanting to play with it, and you know, once I had spent a week with it, and told Anya, you know, I'm an hour away from chord diagrams, and I think that was 2 months ago. You know, math is hard. But okay, so just to jump back from this for a minute, I'm going to just very briefly look at a couple of pieces. Get them up front. See. So this is just a very brief plug for my talk at the Tableau conference in October, which is on drawing in Tableau. And this is sort of how I think of drawing in Tableau. It's like a dot-to-dot picture, or a connect-the-dots picture. That there are points in the XY space, and they're numbered, and maybe there's different colors. I think I could add colors at one point on this, but I took them out for some reason. So if the dots are actually different colors, then you know to pick up a different crayon when you get to that point and continue with a different line. So, so that's one way to think about sort of drawing with Tableau, and there's some subtlety to that. And I'll maybe spin this ahead a little bit because it gets a little tiresome to watch the whole thing. But you can animate drawing in Tableau by using the pages shelf. You can do all sorts of things, but you're still really just using that idea of points in XY space and essentially two dimensions, which in this case are called polygon and record ID, like a sort of a polygon ID and a polygon order. So I'm thinking of these. Those are when you're drawing a picture in Tableau. Those are essentially the only dimensions that are in the view. Every dimension in the view is going to be part of either the polygon ID or the polygon order. So that can be a really confusing issue for folks, like if they're drawing lines on maps connecting data that has zip code, city, and state. That was the question I saw a lot on the Tableau forum, that these lines were breaking across state and they didn't know why. And that's because since they maybe had an order that went from 1 to 2, that they had multiple different ID fields that were breaking up the lines. So I maybe didn't explain that very well right now, but it'll be better in my talk. So I didn't want to give the whole thing away. So this is the first BMGM Lion and the Tableau conferences at the MGM grant. Okay, so to draw these chord diagrams in Tableau, I am using Bezier curves here. And one trick to go in and sort of look at the guts of this, one trick that I use a lot when I'm building these complex pictures is to make copies of my data. Essentially, I draw a lot of pictures in advance. I think that's my most important tool for making these custom chart types is a pencil and a piece of paper. I draw the picture first, I number the points, I figure out what it is that I've got to do, and then I do the math behind it. So in this case, there's to look at the data source maybe behind it. I've got essentially four tables here, 4 text files that are coming in. And chord data 1, chord data 2, they're exactly the same. They're carbon copies of one another. But the reason I have 2 of them is because I'm joining name 2 with name 1 and name 1 with name 2, which is very confusing, but it's because I'm going from point A to point B, and I need both those numbers, both those sort of frequencies in this picture. So I had to get them on the same row, and I was avoiding pre-processing, so I did it with a join. The other data sets that are in here are a little funny looking. Maybe I'll connect to those individually. I used to know how to connect to data. New data source. There we go. So it's text file and 2 copies. Looks like this. It's got 2 rows in it. One of them is called base, and one of them is called dummy. Don't be insulted by the dummy that you'll see a lot in my workbooks. It's a dummy column. Essentially, I'm using that to create a cross join in Tableau, which doesn't have cross joins at this point. So I'm joining on dummy, which gives me all the possible combinations. So joining with this will give me 2 copies of my data, which explains the name. And then 5 copies. You might not be too surprised that the structure of that is numbers 1 through 5 and a bunch of 1s. I could have done this with a single data set that has 10 rows in it. That's not how I did it because of just how I think. That the 2 copies is for my points my lines that are going from point A to point B, so it's along that path from 1 to 2. And 5 copies, we'll see in a second, is because I'm drawing multiple elements in the viz that I'm going to need to use points more than once. Right? Tableau, sort of out of the box, is only going to want to show a point in one spot for you. So you can get, or rather a row is only going to display in one point on the screen. If you duplicate your data, though, of course, then you have multiple copies, and you can put those wherever you want. Right? So going back to the viz, I can break up those copies and look at what each individual one of them is doing for my picture. And I can do that by just putting it on word shapes. Cancel that. And so copy. I'll just drag that out. So I am doing densification on the 2 copies, but not on the 5. So here's what my 5 copies of the data are doing for me. And when I put in 5 copies, I was actually thinking I'd probably use 3, but I know myself well enough to know I want to include a little overhead so I don't have to go back and redo stuff. So I figured, okay, I'll just add a couple extra and do 5. Turns out 5 was exactly the right number for this. So here's the chords on the interior. The exploding donut that's around the outside of the chord diagram is broken up into 2 parts, and that's just sort of an artifact of how I'm using the data. The fact that I'm filtering half of it out because there's some duplication when you bring in all the rows and then you join it with itself. Then the path from A to B is the same as the path from B to A. So essentially got rid of half of them. The labels, of course, which the labels is probably one of the biggest struggles that I had with the chord diagram in Tableau. just getting the placement right. I'd really like to be able to align the stuff on the right to the left side and the stuff on the left to the right side. Didn't find a good way to do that. I'm experimented with some things like putting white text to the left or the right as needed, but it just was clunky, that solution. And then so copy 5 was the one that I think is sort of interesting because it looks exactly the same as copy 1. And then it's the exact same picture, but it's gonna highlight differently. So you see as I roll over something, and that was another very tricky piece of this chord diagram is that if I am highlighting on an action, say I roll over the sounder here, I want all the Apple copy in here. I want all the chords that come out of the Apple arc to highlight when I roll over that Apple arc. But those chords are also part of one of the other arcs. So there's 2 different selections that should result in that being highlighted. And the only way I could find to make that happen in Tableau is to just make 2 copies of it. So I'm highlighting one or the other in a given situation, and the selected one is always going to show on top. So it worked out great. Okay, so I mentioned that I was going to make it easy for people to plug in their own data sets. So here's another chord diagram I made that's Uber rides by neighborhood in San Francisco. And there is, in my blog post, there's a Excel workbook, my first Excel workbook, I think, in a blog post that goes step by step through some of the pre-processing. There is a little bit just using the reshaping tool to get things out of a matrix into more of a tall data source. But once I've done that little bit of pre-processing, then switching out my data source is really pretty simple. So I'm going to go in, I said edit data source on chord data. And if you want to make a bunch of chord diagrams, my advice would just be to make a separate folder for each of them. In that folder, you want to have 2 copies, 5 copies, and 2 identical copies of your underlying data. That would be the reshaped data from Excel or wherever you're getting it. And so the swap happens here is I just go in. I'm on my Uber data folder. I'm going to go to chord diagrams, phone data, and just any one of these I think will work. It'll take a moment to update, and then here's where the magic happens. That was it. So I took my Uber chord diagram and I just made it into a cell phone chord diagram with a couple of clicks. So hopefully it'll be that easy for you. This is sort of in the beta phase at this point, so if it's more difficult, then drop me a line and maybe I'll see if there's something that I can make a little simpler about it, and we can help get this into a production version. Okay. So I've probably talked for my time, I think. Are we going to go back and have a little panel discussion or anything like that?
No, there was one question that came up just about when is it most appropriate to think about using a chord diagram and for what business problems?
That is a very good question, and that's one that I talked about a little in the blog post, is that I'm not sure. Certainly, I think chord diagrams that I've seen that I think are effective are sort of migration data, not necessarily geographic migration. This is sort of cell phone migration that we're seeing now, but it's a fairly narrow use case as I see it. There are a lot of people who would say you should never use a chord diagram because look, there's an exploding donut right around the outside, and that's bad, right? So So part of my motivation here was to just give us the ability to experiment with it and see if we can figure out when it works and when it doesn't, and have the conversation in Tableau.
If I could jump in on that one, I Noah and I had long email threads about this, as well as other people that I talked to and asked. If anybody knows me, I always like to look at best practices and do these types of visualizations work. And I was probably a naysayer of this chart in the beginning. Stephen Pugh and I traded some emails about it, and he sort of convinced me that it actually does have some use cases. And when we all three of us sort of talked and looked at alternatives of something like this, there's a bunch of challenges. If you put the data on a map, it really is chaos. If you unwind the circle, it becomes, pi times longer, either down or wide, and so it becomes a very wide or lengthy chart. So if you have, I think, that specific use case, I think you do come back to this is a compact solution to show the flow from one part of a closed system to another part of a closed system. The other thing I would point out, whether it's the sankey, the slope diagram, the chord, the hive, if you don't have interaction, I don't think any of these particular charts are going to be useful. If we've all lived in a world where executive wants something on a piece of paper, these charts aren't going to work for much of anything other than pretty something up on a wall. So I think the interaction that Noah talked about really is key to making any of this stuff work.
Yeah, so you heard it here first. Stephen Pugh saying chord diagrams are the best.
No, I did not say that. I did not say that.
So there was also a question related to data, the size of the data. Are there limitations to think about in terms of rows of data, size of data, to think about when utilizing a chord diagram?
In terms of the workbook, I've made it general, so any size data should work. I mean, it's going to get slower. You'll notice the Uber chord diagram is slower than the phone one. If you can have just one category, it's very fast, just circle. But so technically in Tableau, there's not a limitation that I know of. In terms of in practice, it's probably like anything. The more you get, the harder it's going to be. I don't know, Jeff. Do you have any thoughts on that?
I have not seen any limitations. I'm only really multiplying in the sankey or slope by 49, so every row of data becomes 49 rows of data. But I've seen some examples, people emailing me where they're putting in thousands and thousands of rows, multiplying by 49, and it doesn't seem to have any problem plotting that. You're really just plotting points, and it's not wide data; it's just tall. It's not high dimensions.
Yeah. One thing that the chord diagram for Uber, the Uber data has a lot of chords on it, but I think one thing that makes it work a little better to me is it doesn't have a separate color for every neighborhood. It's got some clustering from the original Uber blog that they did some clustering on it, so that the color scheme that you see or will in a moment see on this chart, there's only a few colors that actually play a role in this. So that might be a more important limitation, I think, than the number of chords.
Well, I think that's our last question, and it's getting to the top of the hour, so I'd like to try and wrap things up in honor of everyone who attended and try and keep this down to an hour so folks can make other meetings in their day. Jeff, Chris, and Noah, thank you so much for coming on today and for sharing these diagrams. Again, all of, as I understand, all of the posts and all of the examples will be online. We can put links to those on the Think Data Thursday group site as well. And I hope everyone finds this really helpful. It's fascinating to me to watch as well. My name is Patrick Vanderhyde. I know I show up as Tableau software, but I'm Patrick Vanderhyde, and I'm in the community manager on the support side for our forums. And if you have any other questions, if you have any other great ideas for a Think Data Thursday, please do not hesitate to reach out to us at the community@tableau.com email address, and we'd be glad to try and address those. We don't have a next plan to Think Data Thursday at this moment. We're getting kind of close to thinking about TC in October, and I know a lot of folks are having presentations that they're kind of putting together for that. As Noah mentioned, he'll be presenting there as well. And so if you're not already signed up for that, I think you might want to check into it at least. I went first as a customer and found it as a great opportunity to learn more about Tableau. So that's it. Thank you guys. Thanks for coming on today.
Thanks, Patrick. Thanks, Patrick.
Okay. Take care. Okay. Bye.